So the aim today in our goal is at the end of the day, we hope that you can handle some big data on with our session, and you can manipulate to some visualization of your data and some summarize of your data. That we will present some running are on a cluster, some at distance, and at the end of the day, we hope that you can also use some traditional machine learning on big data, like penalized regression, principal component analysis, or partial least square approach. And all of this on real data case. So this is our aim of the day, okay? So for the data we will work today, we call it big data, but there are many ways of characterize big data. So they different shape, in fact. So we have the wide data, the tall data, and the tall and wide data. So wide data is when, in fact, you have a lot of variables and not a lot of subjects, so observation. So we have, in fact, we say we have P, which is the number of variables, which is larger than the number of observations. So we have a wide data. So to deal with this data, most of the time, in fact, you can be faced to an issue of overfitting the data because you have a lot of variables. So we need to remove some variable and maybe to do some regularization. So this kind of method could be do some screening on some lasso, on some support vector machine, or some set-wise regression to deal with this data, with the wide data. Another big data is when you got some tall data. So tall data is meaning that you have some variable, some information for your problem, but you have a lot of observation, and this is quite challenging also because finally your n is greater than p, so the traditional method could be also could be applied, but as you have a lot of observation, you can sometimes use more complex models. So instead to do just a linear model, you can do some non-linear model, and you can use many interaction and so on. But the most complicated will be to perform some sophisticated method on these huge data, because most of the method is the number of computation is in order of n, which is very large. So it will be time consuming and you have some trouble to perform even the traditional approach. You will see later, clarify this later. And finally, we have the tall and wide data. So thousands of millions of variables and millions of billions of samples. So this is a big challenge. Okay? So how to deal with this? Many options to deal with this. So you need to exploit some sparsity. So to try to select some variable also, to do some variable screening. You will see that to deal with this huge data set, we can use some divide and recombine strategy like MapReduce. So we will introduce all of this later. So today we will work with some traditional data set in the world of the big data world. So maybe who knows the MINS data set? We have already heard about this. Okay, so the MINS data set is have been used to some image I think you have some image later in the material. Okay, so the data set is some image which is characterized by 28 by 28 pixel grayscale images. And so this 28 by 28 give you 784 columns, which is each pixel. And you have in this tall data set, we have 280,000 digits image, which is 0, 1, 2, 3 until 9. And the goal is to predict the digits based on the information of the image, of the pixel. A data set which is quite famous when the big data field start to work on it. It was the airline data set, which is the data set which about the flight arrival and departure from commercial flights in US. So we have there 120 million records and 29 variables. So I will present you this data set too very quickly. Pierre will do this. We will work on the famous data set, which is a Netflix price data set. Who know this data set? Netflix data set? Nobody knows of this? So it was, you can explain it quickly? Okay, so it was a price, it was a competition to design the best algorithm, best methods to rate. Okay, there are some customers who rate some movie, and we want to predict if we have a new customer, which rate we will for a movie which he has not seen yet. Pretty clear? Almost. Okay. And as I'm keen of omics data, we will also apply this method we will present today on genomics datasets. So 4 genomics datasets. The first one is about breast cancer gene expression data with 17,000 genes and around 500 patients. So is it a tall or wide data set? My first question. Wide? Wide, okay, sure. And second data set is a genome wide association study on cardiac fibrosis with 660,000 SNPs from 300 patients. Wide or tall? Wide, okay. Boring, eh? Always wide. After we have some data set on colon data, which is about cancer colon patient. We have the outcome is 40 tumor samples and 22 normal samples, and we have just only 2,000 gene expression. Wide or tall? Wide, okay. And the last one is a simulation of, in fact, I will explain later. This is our big data for today, and this has already been our big issue for this week. With all these data sets you try to download, with the data is about this number of genes, 1,340,000 genes, and 3,000 subjects. So we can say that is wide and tall, because we have a lot of subjects, but it's very wide too. Okay? Okay. So with all of this data, what to do if we want to see the data in an R session? So what is the limitation now on an R session to visualize or to export, to import the data in an R session? So, and what kind of machine learning tools can we use in R to analyze this kind of data set? So we need to get some solution and tricks to do this. So now I will introduce Pierre, which will talk about the limitation in R to deal with this data.
Just 1 second. Which is data sets. This one?
Thank you, Benoit. So I just want to warn you that the part I will present this morning is probably a bit more technical than what Benoit will do in terms of on the computing side, I mean. Why I did that, I think it's just because Benoit took a lot of time to send you all these big files, and as some of you have seen, this can be a problem. But there was something that you didn't see. It was the time we took to create these big files, all right? Because these big files, they arrive in different formats, and in fact, there is a lot of things to do before we are able to create some very simple files which are still big but that you can use. So I wanted to show you these things. So we start with the MNIST extended MNIST data set. So Benoit explained this data set. So basically, in this data set, you have images like that, right? And the first thing to do is to download the file, right? So I gave you here some code here. You have all these codes that you could try at home. So don't do that here because it will take 30 minutes or something like that to download. And if 100 people start downloading at the same time, it will be a nightmare. So you don't want to do that. But you can still try that at home, right? And this file here, you need to unzip that file, all right? And after that, you obtain, when the files are unzipped, you obtain these files, all right? And these files, in fact, they are type of binary files. Okay, so because they are binary files, it means you cannot open that. First, it's too big to be opened, and second, you cannot open that with a text editor or Excel or R or whatever, right? So you need to be able to read these files first, and this is why I created this read bin data function in R, which is a function that is able to read these raw data, basically, all right? So if you want to do that at home, later on this weekend or next week or whenever, you will have to copy-paste these codes, and you will be able then to read these compressed binary files, all right? And when you will have done that, then I created this extract images function in R, and with that function, you are able to extract a certain number of images, all right? And for example, here I extracted 10 images, and then I created this small piece of code that enables you to plot these 10 first images, right? So this is what you get at the end. All right. So when you extract these images with this first function, you obtain an array, a big array, a three-dimensional kind of matrix, all right? And in fact, when we want to analyze these data using statistical methods, usually we need matrices, right? So this is why I also created this extract images to matrix, and with that you will be able to extract the raw data into a big matrix, all right? So if you type that thing, then it will take quite some time, and then this afternoon, I think, Benoit will explain how to use this big memory package to incorporate this data into the R software and be able to deal with that, all right? So this was the first example where you have a binary format for the original data set which is not ready to use. All right? So you can use that kind of code that I provided for that. The second example is this airlines data set. All right? So this is, once again, a very big data set of 12 gigabytes. All right? And one of the problems you will encounter when you try to analyze big data sets is sometimes these big data sets are not clean. Right? So you need to understand if there are some problems in the data set. And this can be done before using the R software. And this is what I wanted to show you. All right? So the original data can be downloaded from these websites here. Currently, they are not working because Trump shut down the government. So because of that, these websites are not working anymore. So you have to wait. It's reopened, right? But so maybe wait a few weeks, not more, I hope. So as you can see, just downloading the files can take. It took me 25 minutes from the uni, so it takes quite some time. So I don't want to do this now. And using all these Linux tools, for example, so there is a Linux tool called wget. All right, you can download several files at the same time. So here I download the files 1987, 1988, and so on until 2008. So I can download, I don't know, maybe 12 or 20 files in just one instruction. Right? So this is the power of using command line Linux tools. Once you have these big data sets, you want to have some look at this big data set, right? So you cannot open a 12 gigabyte data set with a standard text editor or even with Excel, it will not work, right? But still, you want to have a quick look at the very beginning of the data set or the end of the data set, or start sorting some columns, computing if there are some missing values or some kind of problems, all right? So you always do that when you have a small data set. When you are a statistician, you are used to look at your data and kind of see if there are any kind of problems. With big data sets, as Kerry mentioned, you have big problems, all right? So you need to know a few tools. And I wanted just to show you a few of these tools that I used to investigate these data sets. And when I did that, I found a lot of problems, all right? This big data set was used in a lot of competitions. And in fact, people didn't do that job I did, and they analyzed a wrong data set, basically. So there were some problems in this big data set. So there are a lot of tools. We don't have the time because not anybody has all these tools to analyze this thing, but I just wanted you to show that there are some problems before starting analyzing a big data set directly with the R software. All right? What I did here, I timed several different functions using this time function in Linux, several different ways to do a different type of tasks. And you can see that if you try to use the R software, it could take, I don't know, 10 minutes. With these softwares, these command line tools, it could take 2 seconds, for example. All right? So knowing these tools, when you have to do this type of stuff many times, it will save you a lot of time. So there is a learning curve here to learn how to use these tools. But when you know them, on very big data sets, is very efficient. All right, so I'm going to go quite quickly on that. It takes a lot of time, so you have to try it at home. And same thing here, using this big memory package. Benoit will explain what you can do once you will be using this file that I created for you. All right, but at least you will know how to create this file yourself if you have to do that at some stage. All right. So I told you this is a bit technical. All right. So then there is this other file. So we provided this GitHub account or web page that explains how to create this big data set that was sent to you. All right. Here again, there are a few steps that needs to be done in order to create these big data sets. And when you have these big data sets, kind of a big matrix, then there are some steps to do to incorporate into the R software.
Because this data set is 30.
Yeah. So this data set, the TXT file is 30 gigabyte. And I just wanted to precise when Pierre presented the tools in Linux, which is quite efficient. You have also some similar in Windows. For example, wget, you have a wget in Windows too. So you can install also this kind of similar tools you can find in Windows.
All right, so I talked about these NIST data sets, these airlines data sets. First one, it was stored in a binary format, so you needed some kind of specialized functions to be able to read that into a format that you can understand. Second file, there are a lot of problems in the file itself, so you need to be able to look at the file in a way that is efficient in terms of computing time to be able to find, detect these errors and correct them. So all these Linux tools, the command line tools are useful in that context. And there is this Netflix price. So this file is very big also. So it's a wide and tall file. So almost 20,000 movies, almost 500,000 customers, right? And there is about 99% of the observations that are missing. So there are several ways to deal with that thing, and I will present that in another lecture, all right? So basically the idea is you have all these users here, and you have all these movies, and of course, user A, for example, he didn't see all these 20,000 movies, so maybe you have seen he saw the movie 1 and 5 and 4 and not the other one, so each time he didn't see a movie, there is a missing value, all right? And the goal for this company is to predict for a user a rating for the movies that he didn't see. All right? So this is called the recommender system. All right? And so I try to apply a singular value decomposition, which is something I will explain later on. And this was a big problem for me. So you will see what can happen. And to access this data set in the first place, right? I found this data set on Kaggle. So Kaggle is a platform for dataset competitions or machine learning competitions. So I gave you here the instructions to be able to download a data set from Kaggle. And there are a lot of data sets on Kaggle. So if you want to practice your new skills after today on new data sets, then you can download a lot of data sets here and play with that with some other people, right? So you have here, once again, the process to download another data set. And so this Netflix, when I downloaded that, there was a lot of problem also to put that into a matrix form. And once again, I gave you here the instructions to be able to do that. And then we just sent you the clean file, if you want. All right, so quite technical. And I found this, so this will not be treated. So it's 14 gigabytes. And you can find some other data sets here if you want to play with that. All right. So now I'm going to go on to something else. Limitation. Okay. Yes.
Because 2 minutes. Now the Wi-Fi is working. The password is working now. For the people who haven't managed to get the Wi-Fi, is the solution. This password works now. After connecting, go to general website, which is cnn.com, and accept the term condition page that will pop up. Then we can access to the site. See, site. I don't know.
So any general website you can go to. So connect, and then go to a general website, and after pop the terms and conditions, you need to accept them.
So do you have any questions for this first part of the talk? Yes?
What sort of problems did you have in the
The problems was that the way it was recorded, from what I remember, it was a mistake in the understanding of the times in seconds, minutes, and that kind of things. And yeah, I don't remember exactly the details, but I went to the original web page where the data set are explained, where the data are explained, And then I realized, well, there is a problem without yeah.
So these were inconsistencies in the actual data?
Yeah, exactly. Not in the original data from the Bureau of Transportation from this American company, but the people that created this big data set and put that on internet, they did a mistake here. And then this big data set was analyzed by many people, and it was there was a problem in the original data set. Yeah. Thank you. So, yeah. I hope at the end of the day you will realize that if you want to do something important in terms of treatment of big data sets or data science, Linux is probably a good OS to work with, and Windows is not a good strategy. Right? I'm not totally against Windows. That's not the point, right? And I started with Windows, but then I realized that there are many problems with that, and a lot of tools are already installed in Linux that are not available on Windows, and you need to install them, and still with that, there are a lot of problems, in fact. All right. It's not to say that it's not possible to do things, but I think you are limited. All right, so this part of the talk is a bit technical and maybe also a bit theoretical. And the aim of that part of the talk is, I think, that if you understand a bit more about what is the memory in a computer and how it's managed by the R software, then it will help you to deal with some problems that you might encounter with big data sets and R. All right. So, so the kind of statistical analysis that we will want to do are two kinds, basically. So supervised learning or unsupervised learning. And I gave you here a few terminology that are used either in statistics or in machine learning. Like, for example, dependent variable or response or targets or predictor measurements or inputs or regression or features or independent variables. These are different terminologies used in different websites or contexts. So, yeah. All right, so when I started to work in statistics almost 20 years ago, the advice we got at the time was try to have data set with at least, this was the rule of the SAMP, at least 30 observations, right? So now we changed this paradigm a lot, right? So how do we measure the size of a big data set, right? So you need to understand the different way to measure the size in memory on the hard drive, for example, or in the random access memory of a computer. So you have this very start of a bit, 0 and 1, and then you have these bytes, kilobytes, megabytes, gigabytes, terabytes, petabytes, right? And each time you multiply this by almost 1,000, all right? In terms of very big data sets, so when we started to work by creating the slides for the workshop with Benoit, we tried to find some very big data sets. So these are the data sets that we found. And there are some even larger data sets, right? But as you have seen, it's already very difficult to send you some data sets with only 10 gigabytes or something, all right? So for example, this telescope in astrophysics, they download 200 gigabytes per day, all right, since 2000. So imagine the size of the data set, all right? If you want a really big data set, you can try this very big data set. So it's very for advanced users, all right? All right, so during this workshop, we will focus only on tens of gigabytes. All right, so if you want to do something more, this will not be the topic of today. With the R software, you can still address 8 terabytes of memory, all right? But you need a very good computer for that, and that costs a lot of money. All right? So we have our laptop, so we will go for that. All right? If you go if you want to go even further, right? So we are working today here. All right. So I mentioned that you could do terabytes with R, right? If you buy these 50K computers. If you want to go even further, like petabytes of data, then you need some Google type of infrastructure, and this is expensive. We have to pay for that. For 100 people, this is not possible to organize this here, so we will not talk about that. All right. I gave you a few references if you want to go further with that. All right. So I mentioned all these Linux command line tools that you can use when you start to create or to manipulate these very big data sets. So for example, these are all the Linux command tools that I used to create these airlines and this kind of and the Netflix price data sets, for example. All right. And also this one here. All right. All right. Benoit already explained these things, and I'm going to go to this concept about memory. All right. So I think, in my experience, it's crucial to understand memory when you start working with very big data sets. All right. And I will try to explain why this is the case. So what is the RAM? The RAM is random access memory. So this is a memory that is available to the R software directly. All right. Each time you work with R, it reads some files, it puts that on this specific type of memory, and this is where it works, basically, all right, in a standard way. All right. So you need to understand that. So the very start is you have these binary digits. Right? So these 0 and 1 stuff. And these bits, they are stored in the computer in these small boxes. Right? So each box here, like this one, for example, contains either 0 or 1. And then these boxes are organized in blocks. Right? So usually you have 1, 2, 3, 4, 5, 6, 7, 8 boxes here. Right? And this number here, 201, this is the decimal representation of this number in a binary format, 11001001. Right? And this 60 here, this is the address of these boxes in memory. Right? So you need to understand a bit of that for some stuff that I will explain a bit later on. I warned you, it's a bit technical, this part. But then you will be able to play around. Right? So you have to understand that in the R software, the different type of values, they are stored differently. So for example, if you want to store an integer, right, 1, 2, 3, 4, 5, and so on, it's stored on 4 bytes. 4 bytes, it's 4 times 8 bits, 32 bits. So you need 32 bits of memory to store just one integer. All right? If you want to store a double, a real number, then it will cost you double this size, 8 bytes, and so on. All right? So you can use this object.size function to see what's going on with R. All right? So 4 bytes for an integer, 8 bytes for a real number, 1 byte for a character, 4 bytes for logical, and 16 bytes for a complex number. Right? And you can manipulate complex numbers. I do that myself. I do some research in brain imaging, and in brain imaging, the original data are complex numbers. All right? So it's not necessarily some fancy stuff for mathematicians. It can be useful when you analyze some real data sets.
Question.
Yep.
Why logically is 4 bytes?
Sorry? I don't know. I don't know why they designed this to be 4 bytes. Yeah. That's a good question. Yeah. I tried to figure out the answer. I don't know yet. Yeah, sorry. All right. So once again, these are some implications knowing these things when you start analyzing big data sets. Why? When you analyze a small data set, you read the data set, you do what you have to do, and there is no problem. Right? But when you start working with very big, very large data sets, then you might end up with not enough memory to read the data set. Right? So let's say you have this big data sets, Netflix data set on your hard drive. All right? let's say it is, which is not the case, 10 gigabytes, right? This is stored in a format where integers might occupy just 1 byte on the hard drive itself. But when you incorporate this information into the R software, because each integer will occupy 4 bytes, then this will multiply the size by 4. Right? So you look at the 10 gigabytes on the hard drive, you incorporate into R, and right away you have 40 gigabytes used into the random access memory. Right? So this is something that now you can understand, and I gave you here. You can try that if you want. Very simple example where here what we do, we create this. So of course this path in Windows, it will not work, so you just have to change the path. So it creates this integer.txt file that will contain just one integer, 7. Right? In R, if you want to specify it's an integer, you put this L, big L at the end. So 7L means it's a 7 integer. Right? And in that file, so I can use this WC function in C, in Linux, and that will count, WC, that will count the number of bytes into that file. And the number of bytes is, as you can see here, the number of bytes is 1. All right. So we just in that file integer.txt, we just have 1 byte. And then what I do, I use this scan function in R to read this file, which contains just 1 byte, into this x variable, and the type of x is an integer. And as I explained just above, well, an integer will occupy 4 bytes. Right? So by reading that file, you multiply your problem by 4, basically. All right. Accessing the memory. All right. So once again, this is a bit technical. I'm sorry about maybe it's less interesting than when you start playing yourself, but I think this is quite useful, in fact. All right. So let's say now I create an integer 3. All right. What will happen, as I explained, some boxes in the memory of the computer will be reserved for that 3, that value of 3. Right? What happens really is something called a pointer is created that will contain the address towards that box. Right? It's like when you walk in the street and you have all these houses and you have you put the mail, right? You have the address of the house and the content of the mail within this box. It's exactly the same thing. Right? I explain here. We store here, for example, this large integer, which is a sign integer. So there is a sign, all right? And in fact, R will need. We can only reserve. Sorry. Yeah. Okay. Yeah. So we will use these 4 bytes. 4 bytes is 1 byte is 8 bits. So 4 times 8 is 32 bits. All right. So in these 32 bits, this is where this big integer is stored, and the first box contains the sign of the number, basically. All right. So we need 42 boxes, 4 bytes, to store the integer. Right. So this is just a simple function in R to transform or translate a value in decimal representation, this integer, into these 0101 bits, basically. Or you can use some online converter to use that. So it's just for you to play a bit around at some stage to have a better understanding of what is the memory in a computer and how this R software works with that, so that you will be able to understand some problems you will encounter later. All right? I'm going to show you a very simple example of some kind of problem that is kind of interest. Yeah, difficult to understand at first. So here, now you know that an integer is stored over 4 bytes, 32 bits. So it means you need 32 small boxes to store these 0 and 1s to be able to store this value of an integer in memory. So how many different integers can you store in a computer? With that, this is the number of different integers that you can obtain. Right? Why is that? Because there are 1 box for the sign, right? 1 box for the sign, here. 31 boxes remaining for the other 0 and 1s, right? So it makes 2 to the power of 31 possible, different possible numbers that you can represent. And if you start at 0, then this is 2 to the power of 31 minus 1, which I tried here. So this is the number of different integers that can be stored in the computer. If you are using an old version of R, you might end up with some problems because of that, all right? Because when you create, for example, a big matrix, all right, let's say I create a big matrix, I need to be able to say, well, I want to extract an information at this location. So you need to be able to give the row of this cell and the column of this cell. And this is given in an integer format, basically. It's row number 3 and column number 27, all right? Or it's row number something very big, like bigger than this thing, or a column very big, like bigger than this thing. And in the old versions of R, because you have this limitation of the maximum number of integers that you can have in a computer, then you cannot create a matrix with this number of cells. Right? So this could explain, if you have an old version of R, please upgrade to the last version. All right? This could create some problems on big data sets. You can see here, if I go to 2 to the power of 31 minus 1 to 2000 to 2 to the power of 31, then as dot integer of that creates a missing value. Right? So if you start creating some codes to read data sets, you have some for loops, right? You might end up to some problems in your code, not understanding what is the problem exactly, and this could be an explanation. All right, so some disturbing example maybe. Okay, I consider this value here, 46360, all right, and I multiply it by itself. All right, so I end up with this value. All right, now I do the same thing with 2 integers, right, and then I got a missing value. Now I sum the first 304 integers here. I got this value. And I do a multiplication of these 2 sums. And once again, I got a missing value. All right. Whereas if I take the same value at the power of 2, then this is working. So as you can see, if you start knowing a bit more about the technicalities in terms of memory, then it helps you to understand some kind of odd problems. When you encounter this type of problem, you see, oh, there is a problem with my computer or with my R software, I'm going to throw R away, right? This problem will occur with R, but with Python, with whatever software you would be using, all right? It's not a problem that is specific to R. All right. Sorry. Okay. So here I gave you, so when we wrote this book with Benoit, we created that function get ADDR to be able to read the address, to give you the address of a variable that you just created. So for example, here we create this variable x, we put 8 and 9 in this thing, we can extract the address. So this is the address in the memory, represented in hexadecimal format of where these x values are stored. All right? So you can play around. This is what I've done here. You can play around with these addresses and modify the values using the address directive. So you can ask the software, go to this address and modify that value, and then you type x again, and you can see that it has changed, right? So here, for example, I created 8, 9. I change at this address, I put the value 6, and when I display x again, you can see that the 8 became a 6. All right. So you can play with that to have a better understanding of memory. Same thing for real numbers. All right. So there are a few other technicalities here that when you create an object, you need, I explained, 8 bytes to store the value itself, and there is something 48 bytes that are used to store what we call the header. The header contains the length of the object, the type of the object. Is it an integer? Is it a double? Is it a complex number? Something like that. So this information, it's hidden from you, but it occupies some space, right? And when you start playing with big data sets or a lot of data sets, then these headers, they eat some memory, right? You don't see it. You don't understand why. I just created these matrices, and then all this memory is lost for nothing. It could come from that thing. So you have, I'm going to skip that. You can use this object size here or object size here. You notice the dot here or the underscore here, all right, to have an idea of how much an object that you created occupies of memory into the R software. And here there is something interesting. If you create these X values here that contain the first million integers, then you can see it occupies this thing here, which is 1 million times 4 bytes, as I explained. So 4 million bytes plus this 48 bytes for the header, right? And now if you create these Y variables by creating a list that contains xxx 3 times, and you use this original object.size function y, it tells you that this will occupy 3 times the memory. And in fact, this is incorrect. This is why you should use this other function. And R is smart enough to understand that xxx is 3 times the same thing. So basically, it doesn't waste memory for nothing. Right? So the memory of y and x is still the same. And the memory of x and y combined is still 4 megabytes. All right. So creating y from x didn't create a problem. All right. But it can create problems afterwards. All right. So there is something called modification in place. Modification in place is, well, you create this variable x, 1, 2, 3 until 10, all right? And then you want to modify the 5th value, all right, by putting 10 instead of 5. So when you do that, modification occurs in place, meaning that no copy of x is done. Right? So you have these values into memory, and the R software goes directly into that box, and it modifies the 5 by a 10, or in that set of boxes. Right? No problem for that. So same thing here. If I create this x value and then this y value, by putting x, then x and y, they are the same object, in fact. And you can see that the address of x and the address of y, they are exactly the same. So you didn't waste any space, any memory by creating this new y object. But once you start modifying the x, right, then y and x, they are not the same anymore. So at this stage, there is a copy that is made. Right? So of course, for just 10 values, this is not a problem. But when you just have read 10 gigabytes of information, a big matrix of 10 gigabytes, you do some kind of code like that. And just when you, at first stage, it seems to work, you just modify one matrix by changing one value, and right away, you are out of memory. Right? And this could happen because of that explanation. All right. For loops. Sometimes for loops, they are known in R to be very not efficient. Right? So yeah, this what happens here is, for example, here, if I do this loop here, then at each iteration, the data is copied. Right? So this will take a lot of time. This will create a lot of copies. And if you do that with very big matrices, you will eat all your memory very quick. Right? If you do the same thing using lists, this problem doesn't appear. and then memory is changed directly in place. Right? So once again, understanding what happens under the hood, it helps you when you have these big memories. All right? So you need to understand how much memory is available to R. So you have different functions for that. All right? So when I work with big data sets on Linux, I use this GNOME system monitor. You have the same kind of stuff in Windows, Control-Alt-Del, I think, where you see all the processes and the memory. So you open that, you look at the memory that is available, you load a big data set, you look at the memory, how it's changing, and then it's a way to check if you can have some problem. I gave you a few functions here. If you need to incorporate that into some code, right? So you can do that directly. So this works for, I didn't try that. It seems to work for Windows, and you have the other commands for Linux or Mac, all right? So I explained that you have some problems with 32 bits processors, right? So if you are working with Windows, with an old laptop under Windows, and you have a 32 OS, then this is a very big problem for you. You don't want to do that. So you want to upgrade your system to a 64, though I guess probably now most of the new systems are 64. All right. So I gave you a few recommendations here. Use Linux or Mac, not Windows. All right. At least if you use Windows, be sure to use the 64 bits thing. If you don't, you will get massive amount of problems. All right. If you are able to create a big matrix in the system, you can compute what will be the size that this matrix will occupy in the memory of the computer. This is very easy. If you have a matrix n times p, you know if it will contain real numbers, then it will occupy 8 times n times p bytes, right? So you can do that beforehand, and this is a small exercise to see how much memory. So, for example, this will occupy 76 megabytes of memory, all right? So before creating a new matrix or reading a big data file, you do this computation, and you have kind of an idea of, you know your system, you know how many memory you have on your laptop, you know the type of data set that you can load into the memory. And if you cannot, then you need to rely on some other techniques that Benoit will explain in a moment when I have almost finished.
Yes, almost finished.
All right. Yeah, there are some stuff about sparse matrices that I will explain when I will talk about this Netflix stuff. All right. So,
You done?
any question? Yeah.
Often when you're starting a project, it helps to get some code working and doing transition to larger amounts of data. Do you have any strategies that are useful for that? I know this is a complex question, but
Yeah, I understand your point. Yeah. So, two answers maybe. So the first one, sometimes you have these very big data sets, right? So you have to deal with it, right? So you need to be able first to cut a small part of it to be able to play around with that, as you mentioned. And to be able to do that is not necessarily easy, right? So you need to learn some kind of tricks to be able to cut the data set in small pieces, and then you can play around with just one piece, right? Then you create all your codes, and it's working with all these for loops, everything with a small data set. And then you try to scale the thing with using the whole data set, and then this is where you end up with a lot of problems. All right. So I would suggest to do that incrementally, right? Not going from the small to the biggest one, but to the small to a bit bigger and a bit bigger, something like that. And if you have all this theoretical knowledge that I started to give you about the memory, about what is the memory inside this specific computer, this specific machine, then you can understand some stuff. And I will show you when I will treat the Netflix price. I tried to do it. I tried to do something on that, and I ended up with lots of problems, right? And I will show you the problems that I got with that, and what was my strategy to try to overcome that. Instead of showing you directly the last step that was kind of working, I will show you all the steps and all the problems. So it might give you some kind of, yeah.
Thanks, Pierre, to be late. Just 20 minutes now before the break. So, as you haven't played a little bit with R, you will do some manipulation now, okay, with a huge data set. So we will use the package Big Memory to overcome the problem of the memory limit from R that explain just Pierre now. So if you consider that we work with matrix dataset, with standard matrix, I say is 100 gigabytes, but your RAM is just 64, so you can buy more RAM or use the storage from your disk. So, but to do this is by creating what we call a file-backed big matrix, and this is done by using the big memory matrix. So in big memory package. In fact, big memory package will create a file which is a .bin file which you got, and it will be stored in your disk, and it will be directly accessed from R. And it will and you can work directly in your R session, even if your dataset is bigger than the RAM available from R. So this is the first example. So you don't have this TXT file here, but we'll do this later with another TXT file to show how to create this file, this .bin file. And I have done this for you, but it takes this amount of time. So you will not do this now, because I've created directly this big file, which have been saved in the file you have in your datax.bin. So who has datax.bin? Raise your hand. Some have. Okay, so I will present the first code for the people who have datax.bin, but I will also present the same thing with another dataset with the EMIS dataset. Okay, so just to tell you that this function, what we'll do later, is just read big matrix. You give the TXT file, and you give a name for the backing file, which is this file will be created on your hard disk. And from R, you can access directly, very efficiently from R to this file. So you need to create this file just once. It takes a while, but after is done forever. And after you can load this file in 2 seconds. But the first time, it could take a while. And which is important is you need to put this descriptor which describe the information of your file. And is depending your data, you can specify the type of data you have. Is it integer or is it double? Okay. So to read this big data set, which is 30 gigabytes, okay, you have to do, so for us who have this data set, can we try? This is our first goal, try to do it. So I advise you, first, it will be simple for the trouble of the past, to work with your R session where your data are. Okay, So you you do your, if you have your data set not is the same in a good place, I open my RStudio here on the right. So to put in, to see I'm in the good place, I will show you I'm in a good place. Where is my data? Workshop. Workshop. Data workshop. Where is my data workshop? Up. Lecture 1. And I have my data set here. You can see datax.bin with this 30 gigabyte. And I have the descriptor file, which is datax.desk. So, and I am in the good place because if I look at where I'm working, if I do get WD, get working directory, I am in the good place. So to put in the good place, you can just do by click button. If you want, you put session, set working directory, and you can click to source file if you open where you are in the good place. Make sense or it's okay? Okay, so it's challenge. 100 people, I hope that at least 10% managed to do this example. Okay? So, you do that get your descriptor file, and after, you just, to attach this big matrix, you just need to do attach.big.matrix to this descriptor. And this, it takes this amount of time, nothing. And if I'm looking at my data, the result, the descriptor file, I can say that the file name of my backing file, which is datax.bin, I can see that I have this number of column and this number of row. 3,000 rows and 1,340,000 columns. So who managed to get this example? Woo. Yes, 4, 5. We keep going until 10. But the people who don't have the data X-bin will do the same example with, not the same example, the same thing with the data imins data. Okay? So your challenge for the other people is to do the same thing with the imins data. So the imins data, I have already done the job for you, is the meaning that I have already created this backing file. And this backing file is, the file name is xda.bin. But the information has been saved in the file xda.desk. Jesse, you managed to get it? The big one or the small one? Yes. It doesn't work? Because I wanted that you help some other people who's working. So everybody can, if somebody is working, you can help the people who doesn't work. And you can, I cannot go to everybody, but I can try to figure out some issue. Yes? Yes. Yes. Precision. I forgot to put this lecture file at the first link, but yesterday evening you received an email with just this lecture file. Did you? Yes or not? Sorry? So nobody have these lectures? By what? How do you get it? By the email? Yes. Okay. So if you received an email yesterday evening? From Pierre. It was an email yesterday from Pierre. For those who don't have the lecture, the other people can give by USB key or something like this. Here, sorry. Yes, sorry. Yes. In fact, the .bin file, when you do this, if you never specify the .bin, no, because it is in fact in the description file. So it's in description file. You can see here is a good question. You see the description file is all of this. So this is a TXT file in your computer, and there are all this information. And we say in this information file name xda.bin. So when you do this, is inside this description file, text file, and when you do the function attach.big.matrix, it will read this description file and looking for xda.bin in your computer and load it. Yes? Yeah. Yes. When you download, when you unzip, you have normally 3 files. It was xda.bin and the other file.
Because I've got the whole, so I've unzipped it, but in the data set,
Check.
this is the unzipped version, and so
Yes.
we got their own file.
Where from this data set?
So this is the.
Yeah. Okay. I can. Somebody can give you. You have Alan or not? You have the. You want this to give and. Thanks. But you can play with the emins if you don't have this one, because the emins you should have also. It's not a small one, but it's smaller. It's a light data, yes. It's still 240,000 images. So it's working here. Yep. Yep.
From the first one here, because you said we didn't have a text file, but
Yes.
extract.
No. Use the text file for the response variable is the y. This is the x.
Okay, well, the next one.
Yeah. Okay, so we keep going. So to understand what is going on, now some of you have the data set is about the genome-wide data study, or some of them you're working with the data with the image data. Okay. So you can play now with some basic function to see your big matrix. So if I'm doing a dimension of data X, I can see the dimension of my matrix. Can you do the same thing? And if you write data X, normally when you do this with a matrix, you can see your matrix. But it's huge. So what we'll see here, when you put just data X, which is my matrix, it will give you the address of your matrix which is in memory on your hard disk. Okay? Fine? So I have some basic function which is to ask if my big matrix which I work on, which is data X, which is a backing file, so it's true. Is a big matrix? Yes, it's true. And is a matrix we can share? So we see later. It's true too. So now we have, in fact, it's like you have imported a data, a matrix, which is huge. But I will not be able to do this if I have tried to do, for example, read.table on my txt. It will be impossible because it's too big. Okay? So this is a trick to work with huge matrix by using this file-backed process. So you create a .bin file on your computer and you have access pretty quickly on this file. So what you have to remind at the end is that this process can be long to do the first time, to transform your txt file or .bin, but after it's done forever. And you can access to read it in less than 1 second. So if we do some basic statistics, for example, I use summary of data X and I just use the first 4 columns. I can do it, and it's fast. So I can look at the range of my first column. So for my first column, the range is go to -4 to 2.9. For the people who have ACEMS data, we will have some other results. We have a function. I have a question also for you to see if you follow me. We have some similar function as the which function. So the which function in R is just to select some rows which have some different features. So the function in this package is called mwhich. And in my data set, I have done this function. mwhich data X to these numbers LE. So I'll let you read a little bit. And after I will ask the question, what is doing this? So data X is my data. 2 is say I'm looking at my second column. And I will select all the subjects which have a value of the second column less or equal to this number. Okay, but as I have done some statistics before, I've seen that my second column, the stat was that the third quartile was 0.30. So it's meaning that if I select all the subjects have less than this value, I should have, you got it? How many? 35%. I got it. So it's working. Okay? Okay. So it was just to play, but we don't have time to play. Thanks.
Yeah.
So most important now is we have created a matrix, a big matrix we can work with, we will do some statistics with. And to understand, if you write the name of the matrix, you can see the address of the pointer. You can see the address of my pointer, and what is the point is, if I want to access to the first element of my matrix, I can use the bracket. Data X bracket. I have these figures. It's okay? Okay. And now I want to do a copy. This is a big matrix. You say, it's a big matrix. It will be a mess to do a copy of this matrix. But Pierre explained before. So I did data X copy, get data X. And if I'm looking at what is inside data X copy, as is the copy, and they shared the memory, what we can see that is the two matrices as point the same pointer. You can see the address, the same address. So what is the meaning now? It's the same address. They point at the same address. So if I change the value of my first matrix, my first element, I put an integer 1. First it was 1.6. I put 1. And if I look now at the value of data X copy, you have changed also data X copy. Because is the matrix, it shares the same, they point at the same object in memory. But if you have done this with simple object, we don't have the same in R. Okay? We will not change just one object. So this is change also data X copy. So keep in mind this point. Now, I say, I create the same object, I copy two matrices, same matrix. But now I change one element of my matrix. But it changed the element of also the same matrix because they are the same element. They point on the same file, the data x.bin. Is it clear what I have said or not really? Mm-hmm. So, sorry? Yes? Not here.
Yeah,
Not here.
That's
the difference. So it's a trick to just to not multiply the memory because it's the same file. But if you want to create another matrix and to change and keep of this matrix, you can use which is called deep copy. So if you want to create another matrix at the beginning and after change this matrix but keep the other matrix, you need to use deep copy. This is important. So you will do this, and you can do this on your computer. You will see what is going on. So what I have done to save some time and to not take too much time, I did a deep copy of my matrix data X copy, but I just select the first 10 columns. Okay, and I also say, okay, I want to save also this matrix, this copy, in a bin file. So I put a name for the bin file. I call it w.bin. And I put also a descriptor file, wdesk. So what you have now, if you're looking at in your computer, in your file, you will have a new file, two new files, which is w.bin, w.desk. But you don't have w.txt. Okay? And you have your matrix on your matrix you can work on, which is a bin matrix. And my dimension of my matrix is 3010 column. Make sense? And if I'm looking, is a bin matrix, but if you're looking at the address of the pointer, is it the same as before? It's not the same as before because I use a deep copy. So this, you create another file. Okay? So if you do a simple copy, same file, it points at the same thing. A deep copy creates a double one. Okay? So now if I change one, it will not change the other one. So just to have some information, if you want to get the txt file from this, you just can do write .big .matrix and save in a TXT file. Okay? Okay. Don't worry, the tea break will be still there in 5 minutes, okay? But I will not go through all of this because the tea break will be gone. So let me just 5 minutes and we'll have the tea break. Okay. I have to show you this because it could be a trouble. There are a function, I was struggling with this in this package, is a function which is flush function. You will understand what is going on this. And in the help file, it says this function help you to force any modified information to be written in the file backing, which is the .bin file. Not the TXT file, but the .bin file. Okay? So is the meaning that you have created your big matrix, you work on R, you change some value, but you want to force that this value are currently changed in your bin file. So you need to put flush. Okay. So I play with this. My matrix W, I take the first 3 rows and 3 columns. I have this matrix. You can see the matrix. And now I change the value of the first column and put a 1 on all the value of the first column. You can see this. And I wanted also to put some dim name, some name on the variable on my matrix. So I put var1, var2, var3. So I have my matrix, W, which is some 1 on the first column and some name on the variable. Okay? And I want to see if the W bin file has been changed. Okay? Not just on the R session, but is the W finally changed. So what I have done, I try to import this matrix, the w.bin file, using attached big matrix. So I create a new W matrix. And what you can see, I'll let you think about this. What happened? And what you will expect. As I haven't used flush function, I would expect that the .bin file has not been changed. So when I do again new W from the same descriptor file, I will get the same matrix. But in fact, you can see that the matrix has been changed from the beginning. There's some 1 in the first column. But they didn't keep the variable name. So I Google a little bit, a package, all of this. In fact, it's not so useful, the flush function, and there are trouble in this function in big memory. So to keep in mind that what you do now, when you create this, you import this big matrix on R, you work on this matrix. As it point is, you have a pointer in the bin file. Each time you do something on your matrix, it will change directly on the bin file. So it's not now the previous, the original data set. Okay? So if you want to keep the original data set, you need to do a deep copy and work like working like on another data set, another matrix, which we can work and change the value and all this. Because each time you change the value, it changes on the bin file. But never change on the TXT file. The TXT file will not change. But keep in mind that to create a bin file from the TXT file takes a time to do it the first time. Okay? And you don't want to play each time to create again this bin file. Okay.
Can I have a question?
It will be her fault if you don't have a tea break. Sorry.
Is it possible to change the information contained in the data at the descriptor file?
Yes.
Yep.
Two options. You can directly, because you have the question was to if we can change some information in the description file. So you can do directly in R or open this description file which is on your computer with a TXT file.
Okay.
But you can also do in R. You can tell you after, okay? So let's play with this example to show you how the shared memory works by playing with interaction with two R sessions at the same time. So you will do this and we will have a tea break, okay? So for example, I am in my R session and I work with this W matrix. I'm looking at for example, the column 4, and I select some subject which has in the column 4 some rows which have a value of the column 4 less than 0. I do the mean, I have this mean. I do the standard deviation, I have this standard deviation. Now, I open another R session. So if you want to play with this example, you need to open another R session. So you have two R sessions open in the same time. So you can do this. You also attach the same big matrix. So you have this W matrix, it is in one R session, and you open in another R session this matrix, which is a W, which comes from the same descriptor file. So the same backing file. Make sense? And now, if you change a value on your matrix W in one session, it will directly change the value on the second session. Why? Makes sense. Because W works on the pointer, which is a matrix, a file which is located on your disk. And when we change a value in a R session, it will change in the bin file. And the other R sessions are connected with the same matrix with this pointer. So it's already changed. So this is called the shared memory. You see the utility of this or not? So when you want to do some parallel computing, all of this is helpful. Make sense?